Typically today, we're looking at cooling the grain during the fall, bringing it down to a nice cool temperature for winter storage, and then trying to keep it cool. And the goal is always cooler is better, just like putting things in the refrigerator. Roughly, I say every 10 degrees that we cool the grain, we double the storage life. And so monitoring that temperature, knowing what's going on, helps us to regulate the grain temperature with the aeration system. There's another piece, and that is that insect infestations can be controlled by grain temperature.
Welcome to the Crop Science Podcast Show, brought to you by Wise Genetics. I am Brian Arnell, and I'm coming to you from the campus of Oklahoma State University. Today, we're excited to have on Dr. Kenneth Hellevang, Emeritus Professor of Agriculture and Biosystems Engineering at North Dakota State University. Since 1980, Dr. Hellevang has provided education and technical support on grain drying and storage, energy-efficient structures, moisture and mold control, and flood recovery to audiences across the U.S. and internationally. He has authored over 230 publications, delivered hundreds of seminars, guided thousands of people on practical engineering solutions. His research has advanced safe grain storage and energy efficiency in dryers. A fellow of the American Society of Agricultural Biological Engineers, he has earned himself the highest honors, including the second Global Food Security Award and the Gungelson Countryside Engineering Award, recognizing his lasting impact on agriculture and rural communities. Ken, thank you so much for joining us today. I'm really excited to dive in about your career.
It's nice to be with you. Maybe I just share a little bit of my background and how I strayed into the grain area. I grew up, I say, as a cowboy on a cow-calf operation. Decided to go to college, and as I looked at different options, straight into ag and biosystems engineering, and that was my fit. That seemed to really excite me. So I primary focus going through school was in the structures and environment area. Did that for just a little bit, and then there was an opening at North Dakota State University with a primary focus on grain, but still doing some of the structures work. And one thing just led to another, and the next thing I know, I had about 44 years of doing the grain drying and storage.
Well, and it always surprises me, and I don't know why I'm surprised. I've been to a bunch of grain handling facilities, but every time I go out and see another one, it always surprises me the magnitude of technology that can actually be incorporated into grain bins and grain handling. Can you just describe, first on general, what all tech is now being implemented in storage?
Well, I'm going to start, I guess, a little bit by just saying everything has gotten larger. When I first started in my career, we were talking maybe 5,000 bushel bins. A big bin was 10,000. Today, guys don't even want to mess with those sizes of bins. And that has changed the structural aspect. And so just as you put a grain drying storage handling system together, there's a lot of structural things that need to be taken into consideration. So we're looking at, doing soil tests, determining foundations, and all of these kinds of things that we really didn't do 30, 40 years ago. And then along comes the electronics, and we've always done some temperature monitoring. But when you get these large bins, there's no way that we know what's happening within that bin without having some kind of sensors. And the long and short of it has been that we've done virtually everything with just temperature cables. Now we're trying to take the next step and look at integrating maybe some computer analysis. We're trying to look at carbon dioxide levels and a variety of things that puts a fair amount of technology, electronics part into the facilities as well. So it really ends up being not only a structural piece, there's an electric, just all of the power that's required, and then the instrumentation that goes along with that.
I want to go back because I think this is a good point and serve as a point of reference for those that haven't been around. Can you describe the how big a 5,000 bushel bin is versus the new bins now, which I know there's several hundreds of thousands, if not even close to a million bushel bins. What's the footprint and size comparison of the small versus now very large?
That's an interesting transition. I mean, with a 5,000 or thereabout size bin, we were talking bins that might be 18, 21, maybe 24 foot in diameter. And then we were typically looking at the heights that might be sidewall depths of 20 to 22, 23 feet.
Mm-hmm.
Today's bins, we're starting at maybe 50 feet in diameter. Some of the bigger ones that you'll see at kind of commercial facilities get to be 100 feet in diameter. Even on farm now, we're talking depths that might take us to 40 feet. You go to commercial facilities and we're starting in that, maybe 80, 90 feet depth. And so, yeah, it's just much larger facilities.
Yeah, it's been interesting. At least where I'm at in Oklahoma, we've seen renewed interest in both on-farm storage, on-farm grain handling, and the commercial side getting larger with groups like Gavilon coming in. And so in both realms, I've seen a significant amount of increase on small farm, large farm, and large commercial. And it's just impressive to see some of those large facilities going up and when they start the groundwork and seeing how much groundwork it takes. So, and that's what you're talking about, soil test. What are some of the soil parameters that have to be taken into consideration when putting up a grain bin?
Well, when we're talking these larger ones, typically the contractor will actually come out and do soil boring tests and determine what we call, from the engineering standpoint, what the load capacity is. They're looking at taking this load, and trying to set it on a stable foundation that isn't going to be leaning or tipping or moving. And so it's kind of the old structural engineering aspect that we used to think about major buildings, now moving to agriculture.
And leading into another comment you made, can you describe and tell the audience a little bit more about what is a temperature cable and how do they work within a grain bin?
A temperature cable is just a sensor, and there's different kinds of sensors that we can use. Kind of the ones that have been around the longest are what we call thermocouples, that are two different wires connected together. They put out a electrical signal that depends on what the grain temperature is. And so we'll take that basic sensor, put it into some kind of framework, and then a cable that actually might be a wire cable that hangs from the roof of the silo or grain bin. And then we're checking temperatures maybe every 4 feet in depth, and the accuracy of those has always been pretty good. We typically think that we're measuring within about a degree or two of what the actual temperature is.
So I guess my next lead-in question is, why does temperature matter within a grain bin system or a grain storage system? And if the temperature is off, what can the facility do?
It's that's a whole course in just itself.
Yes, yes.
But monitoring and managing the grain temperature is a critical piece of grain storage. I say that we lose as much grain or we have as many storage problems because we're not controlling the grain temperature as if we would see not knowing what the moisture content is. There gets to be temperature variations within the grain mass that moves what we call convection currents that move moisture within that structure. Even back in the smaller bins, 10,000 bushel bins, if we didn't cool the grain with an aeration system, we would end up with a layer of spoiled grain across the top. And the bigger the bin, the bigger the problem. And so typically today, we're looking at cooling the grain during the fall, bringing it down to a nice cool temperature for winter storage, and then trying to keep it cool. And the goal is always cooler is better, just like putting things in the refrigerator. Roughly, I say every 10 degrees that we cool the grain, we double the storage life. And so monitoring that temperature, knowing what's going on, helps us to regulate the grain temperature with the aeration system. There's another piece, and that is that insect infestations can be controlled by grain temperature. It varies by species of insects, but I usually say that if we get below 60 degrees, reproduction is reduced. We go below 50 degrees Fahrenheit, insects go into dormancy. And for those that are in the northern country where we have cold temperatures, if we bring the temperature down to freezing or a little below, we can actually kill insects. So, knowing what the temperature is within that grain mass is critical piece of managing that stored grain.
So something that I at least tend to think happens more commonly up in your country in North Dakota and up north is high moisture corn. Down here in the South, our corn is pretty low moisture by the time we get it into the combine. But high moisture corn is something that I tend to think of more north. Can you talk about some of the difference of bringing in a low moisture crop versus a higher moisture crop that then has to be dried?
Yeah, there's each geographic area, like you indicate, has a little different scenario. But when I start talking about storage moisture content, I always remind people that there's a difference between market moisture and storage moisture. Anything, and let's just focus on corn. The market moisture is 15 and a half. But if we look at marketing that corn, anything that's going to be in storage or move through moderately warm temperatures needs to be down to 14 and maybe even closer to 13% moisture. So we'll talk first northern region. We might be harvesting corn at 20% moisture. It needs to run through a dryer, bring it down. And today, most of the guys are, targeting depending on where that grain is going, how long is it going to be in storage, and they then determine the moisture content that is needed. We also are a little concerned about not getting grain too dry because the drier it gets, the more brittle it becomes, and we see more breakage issues. And so the market really doesn't reward you for bringing in 10% moisture corn. They'd like to be handling that 13, 14% moisture. And so there's certainly variations. And that's one of the things that I usually will cover in my presentations is that just because they can do it in Iowa does not mean we can do it in North Dakota or even in Oklahoma or Texas. Each area is different.
So as I go through some of the things, and I've got your list of questions, and it's been discussed a little bit for me. You brought up the needs. Talk a little bit about aeration, the function of aeration, the purpose of it, and then those ways that the aeration of the grain can be controlled.
Aeration is the tool that we use to control the grain temperature. Grain aeration is essentially a fan on the bin moving outside air through the grain mass to control the temperature. We're not necessarily moving enough air to change the moisture content. We're just adjusting the temperature. And so the fan or the aeration system is the tool that we use then. If the grain is warmer than outside temperatures, we turn the fans on, we cool the grain down to the outside temperature, and we always would like to be during the fall and winter within 10 to 15 degrees of what the average outdoor temperature is. Used to be that they talked about warming that grain in the spring. That philosophy has been proven to be not the best way to manage your grain. The goal should be to keep it cool. So when we start looking at running the fans in the spring or summer, we would have to be very careful to pick the coolest air and try to keep that grain cool to limit insects and other problems. Now, the old way was just to flip a switch on, monitor the temperature, flip the switch on, shut it off, and use that to control the grain temperature. With the grain cables, temperature cables in the bin, we're now able to monitor outside temperature, grain temperature, and let some type of a computer or electronic system determine when to turn those fans on and off. One of the problems with that is that we also need to know what the outside weather is because we don't want to be running the fans when it's raining or foggy or snow in the air. Those kinds of things are going to pump water into the bin, and that's not desirable. So, what we want to do is to also be able to know what outside conditions are. The problem that we run into is that all these sensors may be working today, but not be working 2 months from now. And particularly when we start monitoring outside relative humidity and using that to determine when to run the fan. So I always caution the storage managers. These aeration controllers are wonderful tools, but they do not replace you. You still need to be monitoring what's taking place and know whether that system is doing what you want it to do.
I can't imagine how the methods that we use to aerate a 5 to 10,000 bushel bin matches the same methods that we do on something that's got a 80-foot base to it. What is it? The same methodology, just at a larger scale, or what does that look like now versus the old bins? I've cleaned out a lot of 5,000 bushel bins in my time because we use the smaller bins on campus for our OGI, our Genetics Incorporated, so our certified and foundation wheat. So I've been familiar with small bins, but I can't imagine the air system on one of those massive suckers being just a fan and an open and a grate.
No, well, the concepts are the same, but the actual equipment ends up changing. We're on the smaller bins, we used to use maybe 3/4 horsepower fans. On these bigger bins, we're probably talking 20 horsepower fans. We would do airflow rates that are typically a little bit higher on the smaller bins, cooling the grain a little bit quicker. When we start going to these larger bins, the rule of thumb is still try to aim for 2/10 of a CFM per bushel. But when you get to the real big bins where the horsepower required would just be too great. And so we'll go with a little lower airflow rate. The fans have to run a little bit longer, but we're still accomplishing the same thing. So the fundamental concept is the same. Some of the equipment, though, is definitely going to be different.
How does the airflow work within such a large pile of corn or soy, or what is is the airflow focused evenly at the base and moves up evenly, or is there a point? Do you focus in center, on the outer edges? How does that work?
If we're working in a grain bin or any place, actually, when we start talking about designing an aeration system, we need the fan, we need vents in the roof, and then we need some kind of distribution system to distribute the air through the grain. If we're doing these bigger bins, a lot of times we're working with perforated floors where the whole floor ends up being perforated. In some of them, we go with duct work. Usually, it's cast down in the concrete itself, but the spacing on that duct work needs to be adequately sized and it needs to be adequately spaced. And we have kind of guidelines that we go by in designing those systems so that we do get a fairly uniform airflow distribution. It's not just putting a fan on and putting a little opening in the middle and letting that air out. All the pieces have to be designed. And if we don't do that, then of course we don't accomplish the goal of evenly controlling the grain temperatures. So there are similarities, but definite differences.
If somebody's listening, thinking about adding storage, on-farm storage, what kind of technology would you suggest that is a must-have for anybody looking to invest in grain storage?
Well, the number one thing is aeration so that we can control the grain temperature. The number two one is the temperature cables. The question usually ends up, how many cables do I need? Because each cable costs money, and we can't. Another thing that is working against us is that grain is a good insulator. And so we might have a sensor located someplace, a hot spot, spoilage, insects show up 5, 6 feet away, and the temperature doesn't adjust. But the typical recommendation is in the center, along the south wall, and then near the north wall. And that'll give you a pretty good guide of what the conditions are. There's a new product that is being used more and more, and that's a moisture cable. They call it a moisture cable, but it really is measuring temperature and relative humidity. Since relative humidity is very difficult to measure, what it does is it takes those two numbers and calculates what they would expect the moisture content to be. But it can be off a couple percentage points, and things don't store the same. 13% and 15% don't store the same. So I think it's something that we can consider, but I wouldn't totally rely on it. Kind of a new thing that's on the market that has a lot of appeal is a carbon dioxide sensor. And that then is measuring the carbon dioxide level. If we have insects or spoilage, a byproduct is going to be carbon dioxide. And that might be for something that we want to look at as another tool, particularly as we start talking larger storages, so that we know a problem is developing before it becomes a major issue for us. The controllers, the computers that go with it, there's weather stations. My experience to this point has been that it requires the manager to really be moderating what's taking place. So it's a tool that you might consider, particularly in larger storages, but the temperature cables, the ability to aerate the grain, and some kind of monitoring system is the basic fundamentals to start with.
It's time for our famous three.
Are you ready to maximize your acres? Discover KWS Hybrid Rye, the high-yielding rye with Pollen Plus technology. Designed for superior growth and resilience, KWS Hybrid Rye helps you achieve greater productivity and profitability. Don't miss out on this innovative solution for your fields. Visit KWS.com today to learn more about how KWS Hybrid Rye can transform your farming practices. KWS Hybrid Rye, growing innovation for your future.
Well, I've really enjoyed this conversation, but we have hit our time limit. I am going to come at you with our three standard questions that all guests get. And the first is, what has been a go-to work resource for you throughout your career?
Well, for my career, I've really looked at the extension publications by other states or the research. Early in my career, Purdue was kind of the place you looked to. They were doing research. They had an excellent extension literature out there. With the tools that we have today, I start with just a search on the internet. But like with any search, I'm a little cautious of what the source is. Is it good information or is it a sales pitch? And so I still lean to what maybe the industry is putting out, but double checking the university information.
So while you are emeritus, which means you're retired, it seems like you're still quite active within the activities. But what do you do for leisurely activity now? What do you do for fun?
Well, for fun, I've spent most of my time with family. I had 3 children and 8 grandchildren, and they're spread across the country, so we follow those. They're all involved in soccer and other things, and just keeping track of everybody is a major fun activity for me.
Fantastic. And finally, is there a place people can go to find out more about your work?
Again, the internet. If you just do a search, it's kind of scary at times. You put in Ken Hellevang, and there's hundreds, if not thousands, of things that show up, and so pretty easy to find.
All right, fantastic. Well, folks, that wraps up another episode of the Crop Science Podcast Show presented by Wysenetics. Thanks for joining us today with our guest, Dr. Kenneth Hellevang, Emeritus Professor of Agriculture and Biosystems Engineering at North Dakota State University. Remember, subscribe to that channel and click that bell to receive notifications if you enjoyed what you heard today. And also, share it with friends, neighbors, colleagues, and peers. Let us know what we're doing well, what we're doing wrong, and if you have any guests that you suggest. Dr. Hellevang, thank you so much for joining us today. It has been an absolute pleasure.
You're welcome.